Hey guys, I know I promised that there will be no theoretical parts in this tutorial series anymore, so not to be a liar, I will call this little sub-tutorial a conceptual one. I have shown those first three parts to a friend of mine, which is not that much familiar with the uFrame, but he saw a few other tutorials like Angry Flappers. And he was very confused with the fact that things like movement, physics and collision are handled in the view even though they seem to be a part of some logical calculations. And I find this question very interesting. That is why here we go with a little bonus tutorial in which I will explain my vision of how uFrame cooperates with the rest of the Unity game engine. First of all, we have to define a few terms I'm going to use in order to make it as clear and explicit as possible. And here we go, problem domain and environment. You should know that view and model-based approaches are not used to describe the entire world, since it's too complicated and you don't really need that. Instead, you want to describe a very small part of the world which is strongly related to the current problem. For example, a bank or an office or a company or a game. So let's make a little example. Imagine any kind of school, you know. There are those teachers as well as kids, and there is stuff like homeworks and exams. There are certain rules and procedures like graduation process and how new kids are getting accepted, or how classes are managed and how are those mapped to the classrooms based on the time in order to create a timetable. On the other hand, you don't care much about what paper homeworks are written on, and also you don't care how classrooms look like. And you are not that much interested in how certain kids are named and what color are the walls of the school, because it doesn't affect how timetables are managed, or how homeworks get passed, or how subjects are being taught in your school. So things that are strongly related to your organization, like a school, refer to the problem domain, while everything else stays outside and considered to be an environment. Your problem domain depends heavily on you as a designer. If you want to know what kind of classrooms you have and how those look like, you can include this information into the problem domain, and then it will not only be an environment, but it will also be a part of this domain, and maybe you will develop related logic for this. Like, for example, if classroom looks like a scrapyard, maybe you would like to clean it a bit. Now let's see how problem domain and environment correlate with MVVM pattern and Unity. But to do this, we first going to take MVVM concepts out of the programming and apply it in the real world. Imagine you have a shop. Your problem domain will include models like customers and managers, as well as goodies. You will probably have some logical rules defined for those. For example, if a customer wishes to buy an item, you sell it. And the word sell actually represents a set of actions, like billing and delivering, if those are related to your problem domain. Also notice that even though customer wishes to buy an item, it doesn't mean he will do it, and it doesn't mean he will be able to do this. If customer breaks something, this invokes another chain of procedures. So in your MVVM models, you're definitely going to have a customer. But now think of properties and commands. Your customer can speak, walk, take money out of his pocket. He can come and leave, stand here or there. So you can create a command for every single action. First, such a list will be infinite. And also, you are not interested in all of those. To make a purchase, customer has to go out of his house, walk along the street, enter your shop, and finally tell the manager that he wants to buy some bread. But the only important thing related to your problem domain here is that customer lets us know that he wants to buy something. That is why, instead of designing customer view model as a human with tons of actions and properties, like weight and color of his nose, you will just need a buy command which will express the intention of the customer to make a purchase, and also you will need money property, most probably. And that's how you design your view models and the problem domain itself. You cut out any redundant information, leaving only the most important stuff. But our domain model doesn't define how the buy event is going to be invoked. This is because it's strongly connected with the environment. Today, your customer, which tells you something like, "I'm gonna buy those apples," and you can transform his words into the intention to buy apples and send an appropriate buy command. This is how you do it in the real world. Tomorrow, you will have a website with a purchase button. And as the user clicks the button, you transform it into the intention to make a purchase, and again you send buy command. This is how it works in the web development environment. But we're game developers and our environment is the game engine. Unlike web, it is very flexible. It may be copied from the real world, like we got physics and collision, we also got 3D space. But when you're in the menu, it will have a lot in common with the website, because there will be buttons and stuff, you know. So imagine for a second that you don't know MVVM yet, and you want to describe your problem domain in your game engine. You want to extract models and logical rules related to your own problem. And you create separate classes for those, and you're pretty much done since those are isolated. But what about the environment? The only thing that connects you and the game engine world is a mana behavior script. So this is very natural to make your problem domain communicate with the rest of the world via the mana behavior script as well. That is why we have views, to read and change the outer world, and sometimes send commands to the isolated problem domain, which in fact is a set of controllers and view models. So let's see how the described vision can be naturally applied to the Angry Flappers tutorial. When you catch a keystroke in your bird view, you basically consider it to be an event from the environment, but the keyboard is not something that too much related to our game problem domain. And moreover, we're not interested in how the bird is actually going to fly. So this keystroke is transformed into the intention of the player to flap, but it is directly handled in the environment without visiting the problem domain part, because we do not care about it. And when the bird collides with the tube, we consider it to be something that is important for our problem domain. And that is why we send command, and after all the logical calculations in the controller side, all the related view models in your game get updated. So the bird is considered to be dead, and you see this dead sprite, and the game is considered to be lost, so you see the game over screen. This game subsystem in the Angry Flappers tutorial basically handles everything related to pipe, bird, and the game problem domain. But we can divide any game into a lot of problem domains and handle them separately. So this is why we can say that uFrame is scalable, and moreover, we can also integrate it with other plugins so that they are just considered as an environment for our problem domains. And I hope this pretty much explains why we're doing such things as physics and collisions and other stuff in the view rather than doing it in the controller. I hope this makes sense, and thanks for watching. I'll see you in the next part.